Hello, and welcome to another YouTube video. In this video, we would be going through some examples on multiple linear regression, and I would walk you through how to use our programming to solve a multiple linear regression problem. First off, we would read through the example and get to understand what is required of us to do in this example. I would also show you the data and some ways we can format the data before imputing it into R. So please stay tuned and make sure you have your R Studio up and ready as we go through this example. So the question says, the owner of a Showtime movie theater would like to predict weekly gross revenue as a function of advertising expenditures. So basically, that expenditure is in thousands of dollars. Historical data for a sample of 8 weeks follow. So basically, they have provided us data with with 8 weeks, right, of information for our analysis. Now, the first question is that we're expected to develop an estimated regression equation with both television advertising and newspaper advertising as the independent variables. Also, we're asked to compute and interpret the adjusted R-square, which is basically the performance metrics we use when doing multiple linear regression. And then we're given some numbers to predict. In order to predict the weekly gross revenue for the following week, we have, let's say the company spends $3,500 for television advertising and $2,300 for newspaper advertising, right? What will be their gross weekly revenue? And then we also have to look for the 95% confidence interval and the 95% prediction interval. So I'll walk you through the step-by-step process and how to analyze the data on R. Okay, so the first thing is we want to take a look at the data. And this is our data set here, right? And you could see how it looks like. So we have weekly revenue. I'm just going to expand this and make it larger. So we have weekly revenue, right, which is what we're trying to predict. So basically this would be our, you can say dependent or target variable or response variable or output, right? That's what weekly gross revenue is going to be. And then television advertising and newspaper advertising will be our input variables or independent variables. So those are some terms that you can call it. So basically like X1 and X2, and then this would be Y. So you can see that it's in thousands, right? So that would be, this would be 96,000, this would be 5,000, this would be $1,500 dollars. Okay, so the first thing we want to do is to format this data before we put it into R, right? Because the way it is here, let me expand this and show it to you. So the way it is here, you can see that the wrap function is turned on, right? And even when I click on this, you could see how this is all set up. If we put this data in R, you're just going to have so many backslash and so many other different things that we really don't want. We just want to make the data as simple as possible for our analysis, right? So what I'll suggest we do is to, first off, we can highlight all three and turn off the wrap function, right? So, and once we do that, we can come here and I could just say, we already know is weekly revenue. I could just change the name and just say weekly revenue. And then this, I could just say, so the television wasn't spelled correctly. And then this, I could just say newspaper because we know exactly what we're we're trying to do there. So all right, so just a very little or minor formatting to get our data set ready for our analysis. So you can go ahead and save this, right, on your computer. I have this data on the GitHub folder, and I'll put the link on the YouTube description. So please go there and download it and basically follow us with this analysis. Thank you. All right, so I have my R code already open. So I'd walk you through the different packages we need, also how we can then use them to start answering each of these questions. So let's go ahead and start. All right, so the first thing I want to do is to install some packages. So the first package is the G-class package, and that basically helps us to do some scatter plot since we have multiple variables. And then I think the next one should be familiar with everybody. So I'm just, if you already have this, if you look at it and you already have these packages installed from previous examples, please don't install them again. You could basically just skip them, right? But if you have not installed them before, please go ahead and install them. So the second package, ggpub, helps us to create visualizations, right? And then ensures that our visualizations are like publication ready. So, and then the last package would be the tidyverse. Also helps us with creating visualizations and doing some data manipulations. All right, so I would load the packages into R. So I'm not going to be installing any of these packages because I have them already installed on my computer. So you can install them, and once you're done installing them, you could just comment them out, right? So that's basically, so you comment them out after you have installed them, right? If you haven't installed them, please don't put the comment, install them first, and then you can comment them out. So now I'm just going to load those libraries. So the first one would be my ggpub. So I'm just going to put an interpretation there so you know. All right, so that's that one. And then the next one is, so you can see I have it already installed, right? So it's just going to pop up for data manipulation. And then the next one would be the G-class, which would help us in our scatter plot. And then the next one would be our read Excel, right? Which I believe everybody should be familiar with because we've used this. We've used this a lot in our analysis. And then finally is the team set, right? So you could basically see it there, right? You can see it says create a publication ready team, and I know it cleans the It cleans the axis line in your data visualization. It removes this axis line and all of those titles. And so things like that. That's basically what this function helps us to do. All right. So I'm just going to put the quick stuff here. It gives a clear. All right. So now I'm just going to go ahead and load all of these packages. All right, so all our packages are basically loaded, and I would then go ahead to import the data. So I like to put that in my very first step. So import data into our studio. So since we're dealing with a revenue example, right, I'll probably just call my data frame revenue underscore data frame. And then we call the Excel function with Excel. So file choose. You know what? Let me load the file first. So theater revenue data open. So if we visualize our data, you can see how clean and neat it is, and you can see our 8 observations, right? So it's neat, it's nice, and we can basically start doing our analysis with this data. And you can see the highest revenue we have here is $96,000. That's the highest revenue that the company has made in a week when they invest $5,000 in television advertising and $1,500 in newspaper advertising. And the lowest revenue they have made is $90,000 in the second week, right? Where they basically invested $2,000 in television advertising and $2,000 in newspaper advertising. So I think that's something interesting for us to see from the data. All right, so I'm just going to use the head function, which would also basically just give us a snapshot of our data. So you can see basically what we were looking at when we clicked on the data here. We could still see it when we do head, but it only shows us the first 6 rows, right? Remember, we have 8 observations. So, but now we're just seeing like the first 6 observations. So please take note of that. So step 2 is for us to look at the descriptive statistics and data visualization, right? This is very, very important. So for the descriptive, we use the function summary, or we use the summary function, let me put it that way. So summary, and then all you just do is ref df. Okay. All right, so this is sweet. So here is our summarized data, right? So we can see different descriptive statistics, right? We can see the central tendencies, you know, the mean, the median, the first quartile, the third quartile, the minimum, and the maximum, right? You can see all of those different statistics. So, so when we look at the weekly revenue, you could see that the mean is around 93.75, which basically, remember, this is in thousands. So which basically means $93,750, right? And then the median is 94, which is basically $94,000. So when you look at the weekly revenue, if we try to just use the mean and the median to look at the distribution, right, of our data, there's some things that we could basically use to know what kind of distribution our data follows, right? We can assume that it's normally distributed, but what if we want to know if it's skewed to the left or skewed to the right? So I would say as an interpretation, right? Let's see. So as an interpretation, we could say when looking at the weekly gross revenue, the median, right, or let's just say the mean is less than the median, right? So you know what? Let's put it this way. Weekly mean less than median. So this is right. So we could say that because when you look at it, the mean is less than median, right? So we can assume that this is a normal distribution and it's left skewed. And then we could also look at the television advertising, right? And if you look at the television advertising, the mean is greater than the median, right? So we just say mean greater than median, right? And we'll assume, let's just say assume a normal distribution and right skew. And then for the last variable, which is the newspaper advertising, right? When we look at it, all right, so the mean is also greater than the median as well, right? 2.475 is greater than 2.4. So mean is greater than median. So all right, so that's basically some way we could try to interpret um, the when we try to look at the distribution of our data, right? But also we could just interpret it based on the mean, right? That, oh, on average, the weekly revenue or the weekly gross revenue is $93,750, right? And then on average, the amount of money the company spends on television advertising is that's basically $3,188, right? And then also on average, the company spends $2,475 on newspaper advertising, right? So we could basically say on average, less money is spent on newspaper advertising compared to television advertising. So those are some interpretations you could also have as your descriptive statistics. So please take note of that. I'm just not writing it on our arrow code here. All right, so the next one is our data visualization. So let's look at the scatter plot, right? We could do the scatter plot and also look at the correlation matrix, because that's all part of, looking at the descriptive statistics and data visualization and trying to understand the relationship going on between the different variables. So this is where we use the pairs function, right? So you can literally see it there, right? It gives us a matrix of scatter plots. So that's what the pairs function gives us. So here we'll just use this sign. So we have television. Did I forget how to spell? Plus newspaper plus weekly revenue. This has to be capital. Weekly revenue, right? And then our data, which is revenue.df. So I'm just going to put an interpretation here so you know what this code is for, which is the correlation. So this is not the code, this is this other plot. Okay, so if I run this, you can see the scatter plot here, right? So the diagonals are basically all of the variables we're looking at. Television and newspaper, our independent variable. Weekly revenue is our dependent variable. So how to read this scatter plot, right? If we look at this, let's just say this is the first column, this is the second column, and this is the third column, right? So this here is basically television against newspaper. And the last one here is television against weekly revenue. So here, television is on the x-axis, right? And then weekly revenue is on the y-axis. Or here, television is on the x-axis, and then newspaper is on the y-axis. So we can see like it looks like almost a negative relationship between television and newspaper, because as the amount of money on newspaper increases, we could see that the amount of money on television decreases. So there's kind of like a negative relationship between the two independent variables. But when you look at television against weekly revenue, right? Remember, television is on the x-axis and weekly revenue is on the y-axis. So you could see that as the revenue for, sorry, as the television advertising amount increases, the weekly revenue also increases too. So here there's kind of like a positive relationship between television and weekly revenue. So my question for you is, can you look at newspaper and weekly revenue and try to tell what kind of relationship is there? But I'm just going to tell you what boxes to look at, right? So for newspaper, this top box is newspaper and television, right? That's what this top box is for, right? And newspaper is on the x-axis and television is on the y-axis, right? And then down here, this is newspaper and weekly revenue, right? So weekly revenue is on the y-axis and newspaper is on the x-axis. So, and then also you could use this box here too, right? So that's up to you. So please take a look at it and tell me what you think, right? Or maybe leave your thoughts in the comment section, right? And let's see. And I'll try to like the person's comment with the correct answer so we can all learn from them. Okay, so that's my question to you, and let's continue. So let's now look at the correlation, right? So we use the function core, which helps us to get the correlation. Then I bring in that. So all right, so let's run this. Oh, so now we see our results for the correlation. So remember, the diagonal is always going to be 1, right? Because weekly revenue, that's just 1. So, but now we can see the weekly revenue, the correlation between weekly revenue and television. There's a very strong correlation, like almost 81%, right? Correlation between weekly revenue and television. So that's a very strong positive relationship between the television and weekly revenue. But then we could also see a negative relationship between newspaper and weekly revenue. And that's basically like a negative 2.1%, right? Or just negative 2.05, right, percent. So a negative relationship between newspaper and weekly revenue, and that's kind of like a weak relationship between those two. And that's basically telling us that the amount of money spent on newspaper advertising doesn't really bring in so much in terms of the gross weekly revenue when compared to television, right? And then also we could see the relationship between television and newspaper. There's also a negative relationship, right? So this is where we start talking about multicollinearity, right? So when we talk about multicollinearity, right? So here we could just see that it's a negative relationship, right? And that is like 55% for multi collinearity. All right, so please take note of that. So let's continue. The next thing we want to go into now is our step 3. But before I do that, for multicollinearity, if this is really close to 1, right, we might want to drop the newspaper variable, right? Because it's probably doing the same thing, or might be telling us the same thing as television. So we want to choose between television and newspaper. Which one do we want to drop? But in this example, we're not really going to drop anything. We're just going to use both of them to run our analysis. So step 3 is to basically build the model. So I'm just going to say building the regression model. And we use the function called LM. So that's weekly revenue, which is our dependent variable. That with our input, television plus newspaper, and then we call our data, which is Yep. Okay, so before I run this, I need to put here our regression equation, because that's very important. That revenue equal to B0 plus B1 times television plus B2 times newspaper, right? So that's our regression equation. So let's run this. All right, and then the next would be looking at our model summary. So I'm just going to say summary bracket model. And if we run this, we could see a summary of our model, right? And I'm just going to give you a minute to basically take a look at the result, right? And then I'll go ahead and explain what each part of the result means. All right, so the first part here in the summary model is the call, right? Basically what that is doing is basically restating what your regression formula was, right? Weekly revenue equals to television plus newspaper, and then giving you the what data you were calling that from. Now the second part is the residuals, right? And the residuals basically show us how do I put it? Should I say what is basically remaining when we look at our predicted values from the actual value? So if you remember, we have 8 data points, right? So this is basically, so 1, 2, 3, all the way to 8 is basically the number of data points we have. And we can see what is basically remaining when we subtract the predicted values from the actual values, right? So the other thing I would state with regards to residuals is that a positive residual indicates that the predicted value was lower than the observed value, right? So let's see. So here we had a positive value, right? So that means that the predicted value, right, was lower than the observed value. And then for the -1, right, it means that the predicted value was higher than the observed value. So the residuals are key, right, because it helps us to diagnose the fit of our model and kind of understand whether the model is under or overestimating the actual value. So that's what the residuals help us to do. The next one is the coefficients, right? And there's some things in this very little coefficient table. The first one is the estimate. The next is the standard error, our t value, and then our p value, right? And then you could see the intercept, the television, and the newspaper. And I'll basically explain what all of those things mean, right? So for the intercept basically means our B0, right? Remember this B0 we wrote here? That's our intercept. So basically this is 83, right? And what that basically means is that if television and newspaper are kept at 0, right? If no money was imputed to television and newspaper, like no advertising money or whatsoever, right? The company would basically make $83,230 as their weekly gross revenue, right? That's basically what they'll make if no money is allocated to television and newspaper, right? And then we can also see that for television, it has a coefficient, right? B1 is 2.29. And what that means is that if newspaper is kept at a constant and television is increased by 1 unit, right? We're basically going to have like 2.29 being added to, so let me, so this would be, so let me just show you here. I'm just going to try and write it here. So basically what that means is that revenue, right, equal to, so if B0 is 83.23, right, plus B1 is 2.29, right? Then we say this is X1 plus, if B2 is at 0, like if no money is put into newspaper, right? But here for television, we only add, maybe we just add just like a unit increase, right, in television. So let's just call that 1, right? Then B2 is nothing. Let's put 0 there. So basically that what that would be is so basically the company would be making 85,520, right, as their gross weekly revenue. So that's basically how that is. So the same thing goes for newspaper, right? So there's going to be like a positive increase because we have a positive signs. These are positive signs here. It doesn't have a negative impact on our weekly revenue. So just to give you some sense of how to interpret the coefficients. All right, so the next thing we want to do is look at the p-values, right, to tell us if our coefficient is significant or not, right? So if we set our alpha to 0.05, right, you could see that this is less than 0.05, so this is statistically significant. This is also less than 0.05, that is statistically significant. So you only want to always interpret your x1 and your x2. We're not so interested in the intercept. So if this wasn't significant, then we'll have to drop it from our regression equation, right? Basically, we'll just have to delete B2 altogether and would only use television because we'd be like, okay, newspaper is not contributing at all, so we don't need it, right? But here you can see that even though we had a negative relationship here between the variable, it was still contributing here, right? Because based on the p-value, it's less than 0.05. So this is some of the things that you want to look for as you do your analysis, right? And then lastly, we want to talk about the performance, right? Because remember the question says compute and interpret the R square adjusted, right? So, but before we do that, I'm just going to write out the regression equation here, like our final regression equation now that we have the coefficients. So this would be weekly revenue equal to, so B0 is 83.23 plus B1 is 2.29 multiplied by television plus 1.30 multiplied by newspaper, right? So that's our regression equation. So the next thing is to the R square adjusted. So it's computed it for us, right? So please take note, because this is multiple linear regression. And when we say multiple, that's because we have two or more independent variables. We do not use this R square. We rather use the adjusted R square, because that accounts for the fact that you have more than one independent variable, right? So we use the adjusted R square. So you could see that the adjusted R square is 0.886, so basically 0.87, sorry, 0.89. So that is a very strong R square, right? So we could just say for the model accuracy, so the model is really good in predicting the weekly revenue based off the television and newspaper. All right, and then finally, we want to see if our model is statistically significant. So the F statistics helps us to do that, right? But we basically concentrate on the p-value, and if alpha is 0.05, you could see that we have a p-value that is less than 0.05, which tells us that our model is also statistically significant, right? So if this value is greater than 0.05, then even if you have the best adjusted R square, statistically, your model is not significant. So please take note of that as well. All right, so we're officially done with step 3, which is building the regression model. We have the regression model created. We've looked at the model accuracy. We've also looked at how to check for if your model is statistically significant. Now we can go on to the next stuff, which is to try to predict the weekly gross revenue. So here it says the weekly gross revenue for a week is $3,500 spent on television advertising and $2,300 spent on newspaper advertising, right? But remember guys, you could see that your data is not like, you don't have this as 5,000, right? This is just 5.0. So we need to make sure we convert this number into decimal places, right? Before putting it into our regression model. So please take note of that. So that's the new data for prediction. So what we have to do, we have to put that new data by creating a data frame, right? So we're going to create a data frame, and then we just say television equal to 3.5, and then newspaper equal to 2.3. All right, so here we just create a data frame with only one row, right? But here's my challenge to you. Try to look for a way where you can create a data frame that has more than one row, right? So maybe 2, 3, 4, 5 rows. And how would you do that? So if you figure out how to do it, put it in the comment section of this YouTube video so that everybody can learn from you. All right, so if I run this, you could see up in my global environment, we now have a new data file here, right? We started with the rev_df, right? Data frame, that's revenue_data frame. And right now we have new_data. So if I click on it, so let me show you something. So on our initial one, let me close this completely. All right, so on our initial one, this is what we started with, right? We had 8 different uh, rows of data point, right, for television, newspaper, and the weekly revenue. Now we just created a new data frame with only 1 row because we're trying to predict, okay, what's going to be the weekly gross revenue if we spend $3,500 on television advertising and $2,300 on newspaper advertising, right? So we're going to impute this this new information into our regression model, which is this, right? So let's continue. So we say prediction, and then now you use the function called predict, right? And we call our model new data equal to data. Then we could just say prediction here. All right, so let's run this. Right, so basically we use the predict function. We call our model that has already been built in line number 34. And then we use this other sub function called new data to basically take the new data we have in line 42. So if I run this, then run it, so you could see. So basically, if the company spends $3,500 in television advertising, $2,300 in newspaper advertising, they will be making around $94,000 in weekly gross revenue, right? So that's basically how you can use some new numbers to do a prediction with your model that you have created. All right, so now we can check off question number 3 because we've answered that. Now let's look at creating a 95% confidence interval. So I'm just going to put this as step 5, which is 95% confidence. All right, so we'll just say confidence interval. So we say predict. We're still going to use the predict function for this model. New data. So for our confidence interval, if you look at the question, it says provide a 95% confidence interval for the mean revenue of all weeks with the expenditures listed in part C, right? So we have to use what we did in part C, right, to for all of the weeks with the expenditures listed in part C. So let's try to do that. So we have another sub function that says interval, and we would call it confidence. So right, so let's see. Confidence intervals. Okay, so this is for all the weeks, but we don't have week 9, which is our new number, right? We don't have that listed in there, right? So we just have week 1 to 8, right? So we could write another code, right, that basically merges our new data into our ref_df, right? That's one way to go about it. Or we could basically just take this and make it new_data, right? So we just have like 2 different outputs. So you could basically see your first output there, and you could see your second output. So, and we have the confidence interval there, right? So you could see that for our new prediction of 94.23, right, the lower confidence interval would be from 93 all the way to 94.85. That's going to be our upper confidence interval. So that's basically different ways that you could do it, right? So I'd leave you to figure out how to do it if you want to merge, if you wanted to merge the new data into our existing data. So if you're able to do it, put it in the description. Put it as a comment in our YouTube page, right? I would look at it, and if it's correct, I would let you know. If it's not correct, then I would give the solution for it. Hey, let's try to make our comment section really interactive, and I think that's one way to go about it. All right, so the last one is to look at the prediction interval, right? So this one is the prediction interval for next week's revenue, right? So before I go into there, just remember, the first one was 95% confidence interval for the mean revenue, right? So basically, on average, what we're saying on average is that for week 9, the company would be looking at making between $93,000 to $94,856, right? That's going to be the, like, when you look at the average weekly gross revenue coming in. But now we're looking at the 95% prediction. Oops, I spelled that wrong. Prediction interval. So this would be, I think we can copy this because it's kind of like basically the same thing, but we could change this to prediction underscore interval. And then, you know what, not to confuse anybody, I'm going to put this as rev df back. Then new data, we would have interval, and then this would be prediction. All right, so this is prediction interval. All right, so let's run this and run this. So we're doing it only for the new data, right? So you could see that the prediction interval, we had our prediction of $94,000, but our prediction interval is going from $92,000 all the way to $96,000, right? So that's basically like giving us some sort of boundary, right, that our actual estimate would be under. So this is how we could basically use R to solve a multiple linear regression problem. So I hope this was helpful, and I hope everyone is able to learn something and practice with this data, right? And you can find more data online to help you practice and improve your skills on how to use R for regression analysis. Thank you for watching this video all the way to the end, right? We really appreciate it. And if you like this video and you want to see more content, please click on the like button, and also please subscribe. Thank you.